Okay guys, so this is the third video of the simulation series. Today's video is going to be a short video. Short means not YouTube shorts. That means the length of the video is smaller compared to the other videos. And so if you see in the last video, we have derived the first model, and in this model we had used a traditional way of building the simulation models, where in the first column we have created 1000 simulations, 1000 replications, and for each replication we have a selling price, a variable unit cost, demand, fixed cost, and then based on that we calculated the total profit using this expression. And once these 1000 replications were calculated using these total profit values, we calculated the average profit, variance and standard deviation, and then the probability of loss. These were the questions to be answered, and we answered those questions using these replications. In today's video, our agenda is rather simple. We will use an alternative method to run the simulation. In this case, instead of doing replications in each new row, we will build a simple model here first of all, and then we'll replicate the output of that model, that means the total profit, using data table option. How to do that we will learn here in this episode. So first of all, let us build the model. So the selling price was $300 given to you in the problem, if you can remember that. If you don't remember, or if you have not watched the previous video, there is no point in observing this video because it is based on the previous video. So please make sure that you complete the previous video before coming to this video. So anyway, this is your selling price given to us, that was $300. Now the variable unit cost was following uniform distribution between the lower limit of 100 and upper limit of 150, and therefore what is the random variate? Random variate is a plus random number into b minus a. If you are finding problem in verifying the formula, then I will extend this b column so that you can see it properly. I will again write this. So a plus random number into b minus a. If you are facing problems with the formula or the expression, then go back to video number 2 or even video number 1. I have explained the formula for the inverse functions for every type of distributions possible. I mean most type of distributions that are normally used. Okay, the fixed cost was following normal distribution, for which the formula is like this: norm inverse, random number, then mean was given as 15,000 and the standard deviation was given as 2500. So this is the formula. And for the demand was following gamma distribution, for which the expression is gamma inverse, again probability, that means the random number, then alpha, and then beta. So this gives you the demand. Again we need to convert this to integer, and so we will keep this entire gamma inverse expression within the int command, so that the actual output returned is an integer, and therefore we will calculate the total profit, which is nothing but selling price minus unit variable cost into the demand minus the fixed cost. So this is your total profit, right? So if I just ask you, what did we do here? We are just creating one replication. This is one replication. See here, in the earlier model this was calculated in the first row, and now in this case we have created a proper model here, and this is the first replication, or you can say this is the first sample. Now we will replicate this model using data table option. How to do that? So first of all, we will write replication numbers here, number 1 to number 1000, because again we are trying to replicate it 1000 times. You can replicate more than 1000 times also, you are free to do that, and I encourage you to do that. But here for academic purposes I am only restricting the number of replications up to 1000. So these are the 1000 replications. Then in the first column, right at the heading, so in the heading I have written the replication heading. So right after that, in the H column, here we will refer this total profit. Okay, and then select the entire range. What is the entire range? Means including the heading also. That means G1 to H whatever, H G1 to H 1001, right? So we will select the entire range. Then we will go to data, what if analysis, and data table. Okay, so now what we will do is, you see here there are two inputs. One is the row input cell, another one is the column input cell. So do we have any row input here? We only have columns here. So we are not extending this table towards this direction. So we don't have any row input cell. So only the vertical direction table is extended towards the vertical direction. There is no extension towards the horizontal direction. So row input cell will be kept blank. And even in the column input cell, you don't have actually any references. You only have 1, 2, 3, 4 numbers. So actually column input cell is also nothing. That means in actual data table formulation, the column input cell is normally a reference. So if there is any reference, based on that the total profit is changing, and we want to create several values of that reference, then only we include the column input cell here. But we don't have any kind of reference of that kind. We just want to replicate this total profit 1000 times. So in column input cell, you will enter any blank cell. For example, here F1, or you can use any blank cell like J1, K1, J10, anything, any blank cell you enter here, and then click on OK. So these are the number of these are the total profits corresponding to this number of replications. That means 1000 replications. Now I will close this earlier model here, because otherwise it will take too much of time to calculate these output variables. So now using this simulation model, we will calculate the average profit. How to calculate? I have already explained these things in the previous video. So again we will use the average function. Average of which column? This time H column. H, right? So now can you see what is the problem here? So if you enter H, then actually instead of having 1 to 1000 replication, you are also including the first heading also, this figure also, which is little abnormal. But since 1000 replications are getting averaged, so just addition of one another value does not change anything. So keep it as it is. So average HH gives you the average profit. Then what is the variance? Variance of var(s) of again HH. This gives you the variance. And then square root of that, square root of this variance gives you the standard deviation. And for the count of losses, you have used the countif formula in the previous episode. For the range HH, then within quote less than and 0. I have explained this formula particularly in the previous video, so please go through that. So this is the countif. What it gives is the number of cases here having a negative profit, that means the losses, and then if you just divide it by 1000, you get the probability. So this is the alternative method of creating simulation model. So but what is the benefit of creating simulation model like this one? So first of all, note that here we have written the model parameters separately, so you can freely change these parameters. So for example, you can change this 120 and then observe the probability of loss. What happens if it becomes 14,000? What becomes the probability of loss, like that? So kind of user friendly in terms of sensitivity analysis, this type of model. Also, suppose this is a very simple model. Suppose you want to add some components, some additional components or some additional complexities into this particular model. So what we will do here, you can just drag these things little bit down, create new variables here, add here, then modify the total profit formula. You just have to change this model, nothing else has to be changed in the replication part of this. So just change the calculations and the interrelationships between the variables in this one model, and then everything else is taken care of by the data table application, and the output is also based on the data table output, and hence it is automatically calculated, right? So this is one thing. Another thing is, if you want to carry on the sensitivity based on the selling price, for example, in this case you have $300 as your selling price per unit. Now one method is that you change it to 400, 200, whatever, and node some value. Suppose you are interested in noting down the probability of loss. So what is the probability of loss at 200 selling price and 300 selling price? So one method is this, that you change this manually and note the probability of loss. So another method is you can use the goal seek function. For example, data, you go here from data what if analysis and goal seek. Suppose I want to see the probability of loss not more than 0.1. So I will set this B17 cell to 0.1, and I will enter by changing cell. That means what is the variable cell for me, my decision variable, that is the selling price. So I will change B2 in order to make sure that the probability of loss is 0.1 or 10%. Then I will click OK. So now it is trying to calculate this. So see here, when my selling price is around 346, then my probability of loss is around 10% or 0.1, something like that. So this is another benefit of developing models like this. So that's it. This was the content of today's lecture. I just wanted to show you how to build the model using the data table functionality of Excel. I am not extending this video any further. In the next video, we will see how to create a complex model using this same methodology. In that case also, we will create a model, single model first for one sample, and then using the data table application, we will replicate the samples and create the output like this only. Only thing is the model will be complex enough and challenging so that you can enjoy. So anyway, hope you have understood the methodology here, and again I am telling you, please practice this at your home or your facility, and be confident that you can also implement it by yourself. And that's it. Thanks for listening.